Thank you for tuning in to Stay Sharp with Razorleaf, your secret weapon for all things digital and manufacturing. Understanding the scope of shop floor technologies, like manufacturing execution systems and process planning, can be a challenge. In this episode, hosts Jonathan and Jen engage in a conversation with industry veteran Darrell Sabourin from iBase-t, who is our subject matter expert in MES and process planning, and has seen it all in manufacturing and engineering throughout his 40-plus year career. Darrell sheds light on all corners of the shop floor, offering a unique perspective and simplifying complex concepts. Tune in for a mini tutorial on MES and process planning presented in a way that provides fresh insights and clarity. Let's listen in with the team now.
Well, welcome back today to Stay Sharp, where we're talking about all things digital related to products and manufacturing. Today, we are here to demystify MES and walk through some of that. That's what we're trying to do, is educate you guys a bit. I am here with my honored colleague, Jonathan Scott.
Hey, everybody.
And today we have a special guest joining us, Darrell Sabourin. Darrell is the bassist and lead vocals for Stone County Band.
Which explains why he's here to talk about MES.
Right, of course. I'm not kidding. There is actually a link in the notes if you want to check it out. But he has also spent the last 40 years in the aerospace and defense industry. So clearly a true Renaissance man. Darrell, tell us a little bit about yourself and your background.
Well, first, thank you for having me. I started off on my aerospace and defense career in 1984, straight out of college. I got hired by an aerospace company called Command Aerospace, which is in Bloomfield, Connecticut. And I got hired as a manufacturing engineer, which I had no idea what that was because I just got a degree in mechanical engineering. And, ironically enough, I had not pursued a job. I was painting houses during the summer during college and having a great time getting paid to get a tan. And never even sent out anything, like didn't have my resumes. A lot of my classmates had nice resumes printed up and they had sent them out to a million places. And sitting at the breakfast table with my mom one morning, getting ready to go to the painting job. And she said, "Hey, Command Aerospace is hiring engineers." And I was like, "Command Aerospace, where's that?" Well, it was within our town. I just had never knew that, it was an aerospace company and I never knew what they built there. So I went, she typed me up one resume on her manual typewriter, brought it down, filled out an application, stuck it in the box. And 2 days later, I had an interview. And the following week, I started as a manufacturing engineer and had no idea what a manufacturing engineer was. I mean, I got a degree in mechanical engineering. So started work there. And first day on the job, my supervisor probably gave me two of the best things that I carried forward for this 40 years. He brought me in the office and he said, "I'm going to tell you two things that are going to stay with you for the rest of your career." And he said, "First thing is, when you're out there on the shop floor, do something. Even if you think it's wrong, do something. Because if it is wrong, you're going to learn what the right way to do it is." And he said, "Don't sit there and wring your hands and try to figure something out to the nth degree. Just do something." And that one there I've used throughout my career. I refuse to sit and just think about something and ponder. You got to go do something, even if you think it's wrong. And the second thing he gave me was train your replacement, because there's no way that you're going to move up the ladder without them having someone to replace what you're currently doing. So I've kind of lived by those two things throughout my career. Spent 18 years as a manufacturing engineer there, had an incredible learning experience because, again, I was, 21 years old, shirt and tie back then, and I was supporting the shop floor, building helicopters where the workforce down there had built helicopters for 20, 30 years. So there was quite an age difference between the two of us, but I was there to learn. And boy, did I ever. So as my career moved along, I went from junior engineer to, ME to senior ME, and then I was made a supervisor. And then I got involved in computers and ERP. We implemented WDS, Western Data Systems ERP, and I was the lead guy on that because I was the youngest guy in the manufacturing engineering department, and I had some kind of computer background because I just came out of college. And after we did the ERP system, we decided that we needed computer-aided process planning. So HMS Software was our vendor of choice. I get to know HMS very well because I was the point of contact at command and doing all the deployment. And they made me an offer to leave the manufacturing world and become part of their team for creating software. And I said, I don't know how to write software. I don't have any computer science degrees. And they said, you know what? We're more interested in your manufacturing background and how you know how the shop floor works. And that's what our software is. And we'll teach you how to be a developer. And basically went from being in the middle of a factory every day to working from home. They handed me these two books. One was a coding book. One was an Oracle book. And they said, just read through these and you're a smart guy. You'll figure it out. And I did. It became very easy for me to read the code. It was logical. Engineers were logical. It's either a 0 or a 1. If, then, or else, all of that stuff made sense to me. So I was a developer for quite some time. And then I kind of went back to the manufacturing arena because I could talk the talk. And HMS Software realized that not only could I do the development work, but I could talk the talk and be able to really explain why the software worked the way that it did and what the thought process was in creating the software. So once I got to be customer facing, we went through some changes. We got bought by a company, and then we got bought by SAP in 2009. That was a huge change because, we were 135, 140 employees, and we just got gobbled up by 84,000,
Wow.
And wow was an understatement because, now that they bought the software package, it had to be rebranded, of course, for SAP, and it became SAP CAMS, Complex Assembly Manufacturing Solution. And in doing that transformation, of course, now that we're carrying the SAP moniker, most people that bought the software expected it to integrate with SAP immediately. And so we had to go through quite the architecture change to be able to be plant-centric and all the things that SAP ERP requires. We had to kind of, pony up and say, yeah, we integrate with SAP. So big learning process there too. Boy, SAP, quite a complex ERP system. It can be configured in a bazillion different ways. And as an MES, you got to be able to handle them all. So then after some time with that, SAP CAMS was decided that they were going to sunset it, and they were going to replace it with something called Production Engineering Operations, and that today is SAP PEO, and that's their MES solution. And I was the product owner of process planning for that solution. And on the tail end of the CAMS product, we had embedded Visual Enterprise, which was another company that SAP had bought, that was Right Hemisphere. And it got rebranded like CAMS did, and it became Visual Enterprise. And that was all revolved around 3D models. It was a viewer. It had APIs that you could interact with the viewer. And we embedded that, and in CAMS, it became VE CAMS. And then VE CAMS then ended up becoming what SAP has today as PEO. And the first deployment we had was at Newport News Shipbuilding, which they build, those little dinghies called aircraft carriers. So that was an interesting deployment. And then the phone rang on a Monday morning and I got laid off. And so very interesting turn of events. I was one of three people that was part of PEO. And I went, okay, well, that's different. And just so happened that a former coworker was working at Lockheed Aero in Fort Worth, and somebody from iBase-t was there. Pamela Schweppe was there, and the person that I reached out to said, "You know what? And Pamela happened to be in the room, and my friend said, "You know what? If you don't hire the guy on the end of this phone, you're stupid." So here I am at iBase-t, and now I work for iBase-t. I started off as a client partner, which client partner role is something that I had never done before, but it was establishing the deployment resources that were needed for an implementation of Solumina. And then the product manager position for process planning became available within iBase-t. And I really felt that that's where, my experience could help iBase-t the most. And although I did enjoy the client partner role, I jumped over to product, and I've been in product now since 2020. I'm the product owner of process planning within iBase-t.
So, Darrell, if I calculated that right, that sounds like 4 companies, 40-ish years, and 1 typewritten resume. That's a pretty good hit rate.
And
yeah,
you know what?
Yeah, and
the thing that occurred to me is like the whole adage behind every successful man is a strong woman. Go your mom.
Oh yeah, without a
You'd
doubt.
be painting houses otherwise.
Yeah, exactly. And I always thought it was funny that, she did it on one of those manual typewriters, not an electric one.
Nice.
And you really had to bang on the keys back then to get it to type.
That is true.
And it was just it was meant to be. Things like that when they happen, and you have no control of the order that they're happening in, you just let it go, and everything works out for the best.
It's no doubt in my mind we've got the right guy here for the conversation, though, Darrell. I mean, with that background, my goodness, right? I don't think I know anybody who knows more about manufacturing processes and the software and the real do-it side of the topic than you. So, yeah, I'm glad you're here to talk with us today and help us understand some of this and help our audience understand some of what's behind MES, what goes on, like what are the parts of the process, that kind of thing. So, I'm looking forward to digging into this.
I agree. It's kind of rare to have both the industry experience and work with the tools as well. So we're very happy to have you here. The other thing that struck me is the bit of advice that your first boss gave you is very much in line with the software that you're working with right now, right? Do something on the manufacturer. So that's what MES is basically focused on. And then training your replacement, which is all of the documentation, all the documents and files behind it. But let's start where we usually do, kind of defining some of the things. So when we say MES, Darrell, what does that mean to you?
So if I'm going to start talking about MES, I'll go to the 50,000 foot level, okay? And it's 3 things to me. It's say what you do what you say, and prove it. Those 3 things are the cornerstone of MES. And again, that's at 50,000 feet, okay? And then, we can get into each one of those and what I mean by each one of those as well.
Yeah, I'd like to do that. That makes perfect sense to me, Darrell. That's logical, right? And how you manufacture something. So let's dig into the say what you do part. So is that process planning, or is there more to it than that? I mean, I think of things like work instructions, process plans, control plan, all that. I mean, can you kind of give us that view of what the say what you do part is?
That is exactly what it is. The process plan. I think that in our industry of things happening on the shop floor, I think a lot of times people don't understand that the work instructions that are being read and the execution of operations that's being accomplished on the shop floor all comes from a process plan. And the process plan is created by the manufacturing engineer. And there are quite a few components of a process plan, you know. And when I start talking about process plans, the three things that are process plan centric are parts, bombs, and the work instructions.
Okay.
So those three things come together as a process plan. And process plan is also, because it's really creating the script to the movie that's going to be shot out on the shop floor. It has to include quality, and it has to include industrial engineering, because the quality guys are going to make sure that you have inspection points in there for making sure that you're following the engineering, and you're producing things to the engineering. The industrial engineers are going to sit there and do time studies, and they're going to say, that particular operation at that work center, I'm allowing you an hour to do that. And they always look at it as, I'm going to do a time study for how long does it take you to build one part, because then if your order quantity is 10, you just multiply that by 10, and now you've got the time span the time that it's going to take to accomplish the work that's at that operation work center,
which then lets you do planning and that kind of thing. But I want to go back to something you said a second ago, and this may be a dumb question, Darrell, so forgive me. But you mentioned like an inspection point. So is an inspection point, is that part of a process plan, or is that part of a control plan, or help me understand how all that works?
I think the answer to that is both.
Okay,
it can be both. I mean, if you're making a detail part, you're building a component. Most of the time, that's just an inspection point. And when I say a part, let's say you're making an angle, right? A 90-degree angle out of sheet metal. You're gonna route the outline to that, and then you're gonna send it over to the brake form. They're gonna put that 90-degree angle in it, and then it's gonna go to inspection. And inspection's gonna say, they're gonna put their protractor on there and say, yay, verily, you produced this angle, and it's got 90 degrees to it, right?
Right.
So that's an inspection point. But when you start getting into, more complex things, then you really need an inspection plan. And, that's, where, quality management systems sometimes come in. And, you've got to embed that within your process plan. Because remember, the process plan is a conglomeration of all these things that in the end, the component or the assembly that you've built has got to be validated to that engineering that was given to you.
Right.
So the process plan better include everything that is needed to not only build the product, but inspect the product.
Okay. So those inspections, those checks are part of that process plan. Do this, check that. Do this, check that. That kind of thing.
Absolutely.
Okay.
Absolutely. And with that, defining the flow of the part as well, with work centers and industrial engineers get involved there, like I said earlier with the time studies, all of that data then goes up to an ERP system. And then an ERP system is the engine that sits there and takes all that into account. When do I need the parts? How long is it going to take for me to build the part? And then how long is it going to take for you to build the assembly? And, ERP runs, and out the product of that is the schedule dates, the start and completes, And so a process plan, I think, doesn't get as much, notoriety as it should. And that's something that I always promote, is that, whatever you see on the shop floor as an order came from a manufacturing engineer thinking about, how is this going to be built? Where is it going to be built? And, how do I make sure that the prove it part of my 3 pieces of MES can happen?
Right. It sounds like that's not like the third step at the end. It's a thing that's going to be happening as we go. The, do, check, do, check. All those checks are going to help you prove it later, right?
Absolutely. And the prove it part of it happens, all through the do what you say part. The do what you say part is, now you're going to execute. What happens there is that you've created this process plan, you send it to ERP. ERP does its trick with scheduling and all that. And then it creates a planned order, right? And that planned order is nothing more than a copy of the process plan. They take a copy of the process plan, it becomes the planned order. And then you've got, production control people that sit and they say, okay, now that is a planned order that ERP is recommending, I'm going to release it. And once it's released, then that is what goes to the shop floor. And then the shop floor is the do what you say part of it. And they're executing the operations and all the work instructions that the ME planned in the process plan.
Before we get to the do what you say part, because you're right, that we need to dig into that. I want to go back to the plan what you're going to do piece, because you mentioned something when you were talking about workstations, right, and how we plan that out. That made me think of another question. You mentioned, all right, parts, BOMs, work instructions, all that comes together, inspection points, all that comes together in a process plan. What about tooling and equipment? How does that fit in? Is that part of that too?
Great question. It is a very important part of that. When I started my career at Command Aerospace, I spent a lot of time in the tool room where they built the tools. And tools can be anything from a flat pattern template that is traced to make the outline of a part to a giant assembly fixture that, where you in my case, built the helicopter in an assembly fixture. So the tooling is a very important part of, a manufacturing engineer's job as well, is making sure that the tooling is there to support the engineering. If the engineering says that, a fitting has to be installed at a certain station and you've got to be within plus or minus 10 thousandths where the position of that fitting is on that station, well, you got to design a tool to do that. And that tool has to be, part of the process plan as well.
So does that fit into any kind of BOM? Because I think when you mentioned earlier the parts and the BOMs, you're talking about like an M-BOM, a manufacturing BOM, right? It organized in the way you need to make it. Do tooling and equipment fit into that? Are they their own BOM, or is there a BOM in play there?
Well, I know within iBase-t, okay, we have something called a bill of resources.
Okay.
Okay, and a bill of resources within Solumina, it's the M-BOM, it's the tools that you need, and it's also the documents that you need.
Okay.
So those three pieces are considered resources that you'll need throughout the manufacturing process.
Okay. So it's like the process plan goes with that bill of resources. The bill of resources includes the documents, the M-BOM, and the tools and equipment.
Correct.
Got it.
Now, a little bit about the manufacturing bill of material and why is it different than an engineering bill of material, right?
Mm-hmm.
An engineering bill of material is part content,
right?
The engineer says that I need to fabricate a -11 angle, a -13 channel, and a -15 outer skin. And, those all are given dash numbers. And put all those dash numbers together and they become a subassembly that's a -1, right? So you get an E-BOM for the -1, it says that I need a -11, a -13, and a -15, right? So that's what I mean by part content. It's the part numbers that the engineer has designed and created. Now, what comes along with those part numbers is you don't make those parts out of thin air, right? So a manufacturing bill of material would then be something that a manufacturing engineer creates, because although I know I got to build a -11 angle, within the notes of the engineering, the engineer tells me it's got to be made out of 2024 T3511 aluminum sheet stock 032 thick. Well, I don't have a part number for that. Okay, I have got a definition of it because the engineer has defined it for me. But as a manufacturing engineer, I need to create a part number. And typically, the part number would be created in an ERP system. Now, in the world of PLM, there's a good debate going on there of, which system should create the part number. Is it done in the PLM? Is it done in ERP? And, it could be done in the MES as well.
Right.
So, when all of these systems start having to talk to one another, the biggest thing that I always stress is, okay, tell me which system is the authoritative source of that item.
Right.
Because that's going to tell you where it's created.
I'm curious, just because we talk to so many different companies, is that something that's standard? It's always in this particular system, or is it vary from organization to organization?
It really varies. If I was going to have my true manufacturing engineering hat on, I would say, you know what? I want to do all that in the MES from a manufacturing standpoint, because I want to be in one system. I don't want to have to log into a PLM system just to create a part number so that I can then add that part number to the manufacturing bill of material, which, typically the manufacturing bill of material starts off as a copy of the EBOM, because I need to build all those parts, the parts content, but there's additional information and additional items that I need to do the manufacturing part of it. I mentioned the raw material. What color are you going to paint it? Well, it's going to be red. Well, I need red paint. When I put these screws together, and I got to put Loctite on it, well, I need to order Loctite, right? So all of these manufacturing things, need to have a part number so that ERP knows about them and can go order them. So that's the huge difference between an EBOM and an MBOM. EBOM is part content.
I love the way you're explaining it too, Darrell, because it is helping people understand that as we move from the drawing-based world with lots of notes to a model-based world, or do anything really to change our processes. If you think about the process of what you need to do, like what you just described about the paint and the Loctite and that kind of thing, take out of it, whether it's on a drawing note or where it is, the idea is that more and more information about the product or the process used to make it is getting added by more and more people downstream, right? Starting off as an idea, engineering adds some design information, but then manufacturing engineers add in the details about how to make it and what else is needed to make it and tools and other things, right? And we just keep layering and adding more information. And the trick is, where do you add that information and how does it all stay connected, like you were just saying?
Right. And I think that, this is a little bit different subject matter, but, MBE, model-based enterprise, is a buzzword these days.
Yep.
And the cornerstone of that is the model being the single source of truth.
Mm-hmm.
And I think we're a ways away from that.
That's right.
Being able to really say that this model is the single source of truth for the reasons that we've just been talking about.
That's right. If you've got a different EBOM and MBOM, how can it be one model, right? So we have to sort that kind of thing out. That MBE topic's probably a topic for another day, but I think it's interesting and relevant to what you're explaining to us.
And
I would love to come back and do another session on MBE.
We'll have you
because I've got scars on that one too.
Well, we'll have you listen to the podcast that we did on MBE, what a model-based enterprise is, and we'll have you back to comment on that.
That would be awesome. Let's leave the MBE conversation as, there's a lot of theory out there right now.
Yep.
Yes.
And being a manufacturing guy, I don't work to theories.
Mm-hmm. Right. You work in realities, creating reality.
I can't build a part on a theory. It just can't happen. So, being the product owner of process planning within Solumina, that's where we're in the process of transforming our traditional MES into a model-based defined MES.
Okay.
And that's a big transition.
Yeah.
It is. So love to come back and talk about that some other time.
I agree. So I'm going to stop asking questions about the say what you do part, because I could keep asking questions. Jen, as she knows, surprised you haven't stopped. Jumped in on me already and told me to stop. So I'm going to switch to the do what you say part. What does that look like? How does MES fit on that, Darrell?
So all of that goodness that we're going to call the process plan, right? That ME has spent, many hours creating that process plan, and he releases the process plan, and the industrial engineering group has their chance to look at it and give their input, and the quality group has the chance to look at it and say, yay, verily, it's got the right quality points in it. And, that process plan is going to be sufficient enough to produce what the engineer has designed. Again, the ERP stuff happens and the order gets created, and the order is a copy of that process plan.
Sort of an instantiation, right? Like, hey, we need one. Now go do it. Plan looked good. Let's go follow the plan.
Right. So as we're building that process plan, we're in a static environment, right? I mean, you're in the office, you're building the process plan, and until it gets approved, you're static. Well, once it gets approved and an order gets created, life changes, because now it goes from a static environment to a dynamic environment. And if you've ever been on a shop floor, you understand what I mean by dynamic.
Yep.
There's a lot of stuff going on down there. And so that work instruction now becomes an order. Whereas as it was being built as a process plan, it had a part number associated to it. Well, now when it becomes an order, it's got an order number. And people that track all these things don't necessarily track it by the part number anymore. They track it by the order number. And so as this order goes through the shop now, that's the do what you say part, right? You've defined everything that needs to be done in the process plan. You've made a copy of the process plan, and now it's out on the order, a work order on the shop floor being tracked.
I'm curious, Darrell, how often is it that you have to make a change to that when you get to the shop floor and the process plan, you figure out that either there was a step missed or it didn't work exactly the way you wanted it to. We have to make a modification. How often does that happen, and how do you correct that?
Here's where the fun begins. Okay.
You haven't been having fun yet? I thought we were already having
well, yeah. I've been having a lot of fun.
Okay.
At this point, as a manufacturing engineer, I've built what I'm so proud of as the perfect process plan, only to find out that when it hits the shop floor, I had it scheduled to go to this machine, and this machine is down for maintenance at the moment. And I have another machine that can do the same thing, but it's got a different work center. So as an ME, I've got to go down to the shop floor because the shop floor guy has said, you know what, that machine's down, and now I've got to make an alteration to the work instruction and say, nope, can't use machine A, need to use machine B. So I need to go out there and do an alteration. Work order maintenance is what we used to call it. There's several different tags that different companies give it, but that would be an example of a manufacturing change. Okay. And then we need to talk about an engineering change.
Yep.
I mean, you put together that process plan and that order is launched against that process plan, and design engineering figures out that the thickness of that part is not thick enough.
Yep.
Now I've got to go and say, all right, I'm designing a new part. I'm giving it a new part number. It's a new assembly. And you sit there as a manufacturing engineer and go, holy crap.
Now what?
I gotta change all that stuff on the process plan. But more importantly, I got to get that changed on the shop floor before they go any further with what they're doing right now. So again, you're back down on the shop floor and you're grabbing up, you're putting all of those orders that are affected on hold because you need to incorporate an engineering change.
Sounds like a very iterative process.
It is, especially with the engineering side of it, and especially if you're working on a new product. Oh my God, you can, before aircraft number one gets out the door, it could have 3,000 changes on it. Because it is being iterated, if you will, by engineering.
Right. And that's the whole point, right? Which is, hold on, I can't do what I said because I haven't said what I'm going to do on that yet because engineering just told me the product's different.
Right. And here becomes the hurry up and wait cycle.
Okay.
Right? The shop floor is eager to build this stuff, and they start building it, and then I walk down on the shop floor and say, whoops, nope, got an engineering change. Stop working on that. Then you play the hurry up and wait game, because, people down on the shop floor, they get paid to build product, and they get paid by the hour, right? And when they're being evaluated on how many products they build, if they're sitting around waiting for you to change the work instruction, you get a little testy at times, because, I get paid to build these parts. If I build 10 a day, that's really good. But because I'm waiting for you to make up your mind, I can only build 6 today. And, I always, had a lot of respect for the people that work on the shop floor, because all they want to do is build parts and assemblies. And they don't want to get caught up in the minutia of all this changed activity that could happen. They just want to build product. So the change process on the shop floor, again, dynamic. We went from static process plan to now dynamic, very dynamic.
So my limited understanding of some of this, Darrell, because I've spent plenty of time working with manufacturers and talking with folks and seeing how they make parts and things like that, is that there's another kind of change, right? Which is not the, we need to make a change because that work center isn't available, that sort of thing, but more the whoops kind of change, right? I was following work instructions and then the tool slipped, and was not quite what it was supposed to be. So can we talk a little bit about that? Is that in this piece of the do what you say, even though it isn't exactly what you intended?
Oh, absolutely. But it also goes back to say what you do.
Mm-hmm.
Because think about the scenario that you just, put out there. We have a defect.
Right.
Right? Now a nonconformance has been created. So that defect has to go to engineering, and engineering is going to say, well, you can repair it,
mm-hmm.
Rework it, or it has to be scrapped.
Or maybe it's fine, right?
Or maybe it's used as is, right?
Yeah.
You're right. So the use as is thing is pretty easy. The nonconformance gets created, engineering looks at it, use as is, you pretty much, rubber stamp it and go about your day. But if there's rework instructions that have to be created to rework it back to blueprint, specifications, then you're back in the say what you do bracket again, because now the ME's got to create a rework work order, and it's got to have instructions on how to specifically fix that defect.
Right. And in this case, this isn't changing the process plan, right? Because you're not trying to change the process. You're just saying, here's what you have to do to fix it to get it back to where you were supposed to be in the process to begin with.
Correct. It is and it is something that happens on a daily occurrence.
Sure.
Because people and processes are not perfect. There's going to be mistakes, and again, that is all part of the process. In that defects, you can't ignore defects, but defects, depending on the severity of them, can have different ways that you have to attack them too.
So that leads me to a question about 2 words. I'm hoping maybe you could straighten that out as we're talking about this topic: deviation and waiver. Like, what do those mean in this context?
I know. I'll give you the definition that we had at Command Aerospace. A deviation is something that needs to be satisfied that you can get it back to engineering. You can get that defect back to engineering. A waiver, on the other hand, says that, I can't really get it back to engineering, but is it detrimental? And you get a waiver for that. That is the definition that we used to use back in my Command Aerospace days.
Yeah, let me restate it to make sure I followed what you're saying there. Deviation is, I'm going to rework it and get it back to meet spec. And a waiver
Correct.
is, I can't make it meet spec, but you're going to tell me it's okay anyway.
Yeah, exactly.
All right, I got you.
Or it's not, and then you scrap it.
Yeah, exactly. Yeah, yep, you're exactly correct. And that's, again, talk about dynamic. That's the shop floor,
right?
A lot of stuff goes on down there, and dealing with discrepancies is, a daily occurrence.
So if that's kind of the tail of the tape on doing what you say, or trying to, right? And in some cases, backing up and saying what you're going to do a different way. Let's jump to the prove it part. So talk to us about, we talked a little bit about prove it when we were talking about the other steps and putting in inspection points, but how does an MES help prove it, or how does it do that activity?
Well, all of the data collections that the manufacturing engineer has put in there, whether a data collection be you have to record a torque value, and there's a spot on the work instruction that says record the torque value here, whether it's just an accept or reject. Hey, I installed this part and it's got a buy off in it. The fact that somebody's got to go click on that buy off is objective evidence that it was done.
Okay. So not every piece of prove it is an actual inspection or a measurement. Sometimes it's just I said I did it, that kind of thing?
No, exactly. And even more, the prove it part of it is that discrepancy that we just talked about, right? There's a discrepancy, a nonconformance was created. It was, dispositioned. These are the actions that were carried out to resolve it. All of that's to prove it as well, because, you've got to track all that.
Right. I know I have a friend who used to work at GE Aircraft Engines. And she said anytime they get a failed part in, they basically had to go back and check its entire history to see if it had ever been out of conformance and what had been done.
Yeah.
So
and that's
where you're referring back to these plans then and these observations.
Absolutely. And that's something, the prove it part really is, it's a technical data package. In the end, this technical data package contains all those artifacts that you collected and you took action on during the manufacturing process of building this part. And that technical data package is something that you have to present to the customer when you're going through the buy-off of the end item.
All that stuff that proves it, basically, right?
There you go. You go. That technical data package is the ultimate prove it.
Yep. I've heard some people call that, to differentiate it from like an engineering TDP. I've heard people call that an end item data package, but same thing, right? That's what we're talking about?
Yeah. Yep, it is. It is. An end item data package, what is that really? It's an all up of all of the individual data packages that were created.
Right.
For sub-assemblies, for assemblies, for detailed parts, even for that matter. It all trees up to that top end item that, when that helicopter used to roll out onto the tarmac, and, they did test flights on it, and they came back and said, okay, test flight was good. That technical data package includes everything that went into that helicopter. And that is the ultimate prove it. Yeah.
That is a lot of data.
So that's why say what you do what you say, improve it. I always say that that's a 50,000 foot, that's what an MES does. But, and we've discussed quite a bit of the weeds, if you will, of that 50,000 feet. When you get down into the weeds, there's probably a lot more that we could cover too,
Sure. So is that end item data package, is that effectively an as-built?
Yes, absolutely. Okay. Absolutely. The as-built is a part of that, and as-built is, what is the part content,
right,
of what is there. And of course that part content better match up with the EBOM where this all started.
Right. Yeah, we better align back to specs, right? It better meet the specs of what was defined in the EBOM. I mean, another piece you mentioned back when we were talking about prove it, and maybe we didn't talk about this, but you're talking about recording things like serial numbers, right? Oh, I put this serial number on that assembly and it rolled up to this other serial number. It's just another piece of prove it. Prove to me you did what you said you did.
Exactly. Serialization is another topic. Boy, we could talk about that for quite some time, because I don't think people understand serialization, and ERP has another kind of a weird view of serialization, because I used to get this conversation used to come up when I was doing deployments, when I was in charge of deploying software with SAP in CAMS. And we'd get into this conversation about, you can't put a serialized child into a non-serialized parent.
Right. You lose it. You lose it.
They would look at me and go, well, ERP lets us do that. And I said, well, yeah, okay. My ERP friends, they don't really care about traceability and configuration. So yeah, they'll let you do that all day long. But I'm telling you right now that if you put a serialized component into a non-serialized or non-unitized parent, you've lost it. And you know what? I used to demonstrate it by if we really had some people that were having trouble with that concept, I would go to the local convenience store at night and buy some lunch bags and come in and put 10 lunch bags on the table and not put any identification on those 10 lunch bags, right? And then take a slip of paper, a piece of paper, and tear it into 10 pieces and put 1, 2, 3, 4, 5, 6, 7. And I'd say, okay, here, go put those little pieces of paper in those bags over there. And they'd go put them in, and they all sit back. And I said, all right, so your product is out in service, and this part fails, and this part has serial number 4 on it. I need to know how that was installed and, all the information about that so that I can understand why it failed. Go find me serial number 4 in those 10 bags over there. And they're like, well, I have to open up every one.
Mm-hmm.
And I went, well, yeah, you'd have to open up every one. So, think about that. Now you're going to go to the 10 airplanes that have the other 9 serial numbers in and say, hey, can I break that thing open for, because I got to see what happened to number 4.
Right.
That won't be, expensive or time consuming or anything like that.
It's all the above. Hit that checkbox right there. So yeah, serialization, another near and dear to my heart.
So I got one more I want to touch on, and I know we're probably running long, but I'm going to ask it anyway. So long. On the prove it point, I mentioned when we got started that it seems like that relates to quality, and I think it does. But MES isn't QMS and QMS isn't MES. Is that right? Or, can you say a few words about that, Darrell?
I think that's a true statement. I think they live together.
Mm-hmm.
They need to interact with each other. How else are the items in the quality plan going to be recorded? Right. Well, they're being recorded in the work order. And where did the work order come from? Well, it came from the process plan. If the planner, that the ME doesn't have data collections that are going to allow you to collect the data to satisfy the QMS, then that's how they all play together.
I do think it's the whole say what you do what you say, and prove it is a great framework for this conversation, and it really does kind of really well define what MES does. What was interesting to me about this was it's not nearly as straightforward and linear as it sounds like it is. It's much more iterative. So you're constantly doing all 3 of those things throughout the entire process.
Absolutely. You can't get around it. That's the life of manufacturing right there. You know, that's how it goes.
I appreciate all that explanation too, Darrell, because to your point, Jen, when he said it at first, I was like, oh yeah, this is straightforward, right? Say what you're going to do what you're going to say, prove it. It's going to be pretty straightforward. And to your point, that iteration and the way you took us through that, Darrell, was a huge help. Really appreciate it.
Yeah. Well, that's why I call it the 50,000 foot level.
Well, we'll definitely have you back for some lower level flying lessons then. How's that?
Yeah, please do. I'm at a point in my career where I have to satisfy that second thing that I learned on my first day of work, train your replacement. And I'm at a point now where it's a priority to me. The more information that I can share of this great career that I've had, 40 years of being in this incredible business, it's my responsibility to share that.
Right.
So the model-based stuff, I would love to talk to you about that, because that has got so many holes in it. It isn't funny.
Yep. It's going to be a fun one.
Yeah. Well, we will definitely have you back. And I just want to remind all of our listeners, if you have any comments on this, if you have any questions, please reach out. Let us know if there's anything that we haven't talked about yet in our podcast that you'd like us to talk about. We're open to suggestions. So please reach out, be part of the conversation. And until next time, stay sharp.
Thanks, Darrell, and thanks, everybody.
You're welcome.
Thank you for listening into this episode of Stay Sharp with Razorleaf. We appreciate you. If you have any questions or comments for our podcast team, or have an idea for a new topic for our team to cover in 2024, please send an email to podcast@razorleaf.com. We would love to hear from you. Until next time, stay sharp.